Hello, this is Lazarus at Telecom Tech, where telecom and networking technologies are simply explained. Today we'll be simply explaining BGP confederations. If you find this video informative, don't forget to click that thumbs up button. And if you find the channel content useful, make sure to subscribe to get updates to newly published videos. Now, in a previous video, I talked about iBGP's full mesh peering requirements, where all iBGP routers within an AS must peer with every other iBGP router in that AS. Otherwise, iBGP will not function correctly. And in that video, I explained the reasons why that full mesh peering is required. If you're interested, it would be worth taking a look. The link is in the description below. Now, in that video, we also saw that this requirement has an inherent scalability problem. As the number of iBGP routers in an AS grows, the number of iBGP peerings you must create increases exponentially, drastically limiting the size of an AS. Now, confederations are a method you can use to alleviate this limitation. So what is a BGP confederation? Well, a confederation is simply an autonomous system that has been subdivided into multiple sub-autonomous systems. This creates a hierarchical structure within the AS, thus subdividing it into smaller, more manageable components. This subdivision helps primarily because it reduces the number of necessary iBGP peerings, but it also helps to reduce complexity while improving the management of iBGP routing information. Now, how are the number of iBGP peerings reduced in a confederation? We'll take a look at these sub-ASs that exist within this confederation of AS 100. Now, note that iBGP routers within the same sub-AS must still achieve a full mesh iBGP peering. iBGP routers, however, within different sub-ASs don't need to achieve this full mesh iBGP peering. Sub-ASs are interconnected via routers that exist on the edge of each sub-AS, as is the case here, for example, between routers R2 and R3. Now, inside the confederation, each sub-AS runs its own iBGP domain, allowing it to implement more specific routing policies internally without affecting external or eBGP peerings. Routers within a sub-AS in a confederation peer with each other using iBGP, and they treat routers in other sub-ASs within the confederation similarly to how they would treat eBGP peers, but they are still considered iBGP peers. Now, to external BGP entities, the confederation appears as a single AS, thus preserving the routing policies and relationships on a broader scale, while enhancing scalability and administrative control within the AS. So R5 here, for example, knows nothing of the internal structure of the Confederation AS 100. It simply peers with R4 in a simple eBGP relationship. So the Confederation structure is there simply to simplify the internal iBGP complexity by introducing this hierarchical structure. Now, one question that may arise is, are all routers within a confederation assigned to a sub-AS? Well, typically, yes, this is the case, and that's how you would most often configure confederations. However, it is possible to have one or more routers within a confederation that are not assigned to a particular sub-AS. Now, take a look at R5 in this topology. It is within the Confederation AS 100, but it's not within a sub-AS. What rules of iBGP full mesh peering apply to such a router? Well, in order for this to function correctly, R5 must have at least one iBGP peering with at least one router in each sub-AS within the Confederation. So if R5 has peered with R4, R3, and R1, then this requirement has been fulfilled. And remember, iBGP peers don't have to be directly connected. Within the AS, routing between all iBGP peers should already be established using an IGP, So there's no problem in R5 peering with any number of routers within AS100, regardless of the physical links that exist between those routers. Now, I have a video about the requirement of the use of an IGP within an AS for iBGP to function. So if you'd like to learn more about that, check it out in the description below. So while the typical configuration involves all routers being part of a sub-AS, it's technically possible to have routers that are not assigned to any sub-AS, but are still part of the main autonomous system. Now remember, this is less common because one of the main reasons for using confederations is to organize routers into manageable groups. By having a router not assigned to a sub-AS, you're adding complexity to the configuration. Now, one last thing to keep in mind about confederations is that the AS numbers found within a confederation never appear outside of the confederation. They are only locally significant. Within a BGP confederation, an extended version of the AS path attribute, often referred to as the Confederation AS path, is used. That attribute works internally to keep track of the path information across different sub-ASs within the confederation. The standard AS path is used for communication with external peers, and it contains only the main AS number of the confederation. So any router within a confederation that peers with another AS in an eBGP peering, such as router 4 in this case, will strip any confederation AS numbers from the AS path attribute that it shares with R5. Thus, routing within the AS100 will use the AS path attribute that includes the internal confederation ASs, while routing outside of the AS has no use for such information. So these AS numbers are stripped or removed. More about the AS path attribute can be found in a related video that you can find in the description below. So that's the gist of BGP confederations and how they are used to alleviate the limitations brought about by the iBGP full mesh peering requirement. I hope you found this video useful, and if you have, please click that thumbs up button. And if you'd like me to address other related topics, feel free to let me know in the comments below. And as always, please subscribe to get updates to newly published videos. I'm Lazarus at Telecom Tech. I hope this video has been helpful for you, and I'd like to thank you for watching.